Okay, so is there anything you want to look at on part two?
Um, no.
Is there anything you need to look at on part two?
I didn't know. Did you guys want to do? You know how it says that we have to pull, um, the little card from.
Oh yeah. What were we supposed to do? We're supposed to compare what everybody else had, maybe. Let's see. Alternative. I didn't cut them out. I did pick randomly, and I thought that was random enough.
Yeah.
Let's see. Were we supposed to compare our answers? Is that what?
Yeah. Part D, it says compare mean from 7A to the means obtained by at least 3 other individuals.
Okay. Well, I got 44,180.
Okay. I got 52,160.
And I got 44,600.
Nice.
I think mine was a little low because I had the lowest salary was one of my numbers.
Yeah.
So that kind of dragged mine down a bit.
But they all fell within.
What was the standard deviation?
The standard deviation of. Well, I don't think that's for the graph. Oh, 113. That's for something else. I don't think we had to do the standard deviation for this one, right? Just the mean?
I guess. I don't really understand the point of that one, but
Well, just that you compare the means, and I would just say that they all fell within the sample mean from the graph. All of our
mine was within the, well,
Anyway.
I thought mine was a little low, but there was that one salary that was the lowest.
Yeah. And then when it said, does it seem to appear to be unusual, I said no.
Okay.
So it fell within the graph.
Yeah.
The possible. Okay. Do you guys just want to do AA, B, C, and D really quick?
Sure.
Okay. So 8A said, what is the shape of the distribution of the sample means for all such samples? And I said normally distributed.
That's what I put too.
Yeah. It kind of seems like that's going to be the answer every time, but then I at the same time I feel like if you count on that, then it won't be.
Yeah.
For some reason.
And then B, how do you know that the distribution of the sample means has this shape? And Well, it says right in there the scores on the GMAT are normally distributed with a mean of 529.
Yeah,
That they're normally distributed. So they took it from a population that was normally distributed, right?
yeah, they called it the parent population in the answer.
Yeah.
Parent population is normally distributed.
And then C, what is the mean of the sampling distribution of the same mean score for all such samples? Well, the mean is the same as the sample mean. So the mean is 529.
Yeah, that's what I got too.
Kirsten, what did you get for D?
Well, I divided 113 divided by the square root of 10 and got 35.734.
That's what I got.
Yeah, that's what I got too.
Awesome.
All right, good.
Okay. Can we do are we good with that?
Yeah.
Yeah, I think we're ready to move into the quiz.
Okay.
Try to open the right one here.
Ready?
Yep, I'm ready. I think this first one has a typo or something.
Why?
Number 3, mine says when using the when taking samples.
Yeah, that's what mine says.
It's kind of strange.
Yeah. I would say it's skewed right.
When taking samples of N, which is the sample size 5, what was the shape of the distribution of the means histogram when the parent population was right skewed?
So since it's a small number, since it's a small sample, it would be skewed right, wouldn't it?
Yeah, that's what I was saying. Yep.
But eventually, if it was a larger sample, then it would come out to be normal, right?
Yes.
Yeah.
Okay. All right. I'm good with that. So number 4, when taking samples of N equals 100, what was the shape of the distribution of means histogram when the parent population was right skewed? So by that same logic, we'd say that it would become normal by 100 or not.
Yeah, I think it would be normal.
Well, we're supposed to consider a sample size of 30 large. So
Yeah.
I would think 100 would be enough.
My only problem is, did you guys look at the homework at all?
Yeah, I did.
Look at number 6. Oh,
Okay.
6 should be normal. So that's correct. Never mind. So 6 is the same question as this, essentially, and it is wrong. Right?
I forget. Well, I can't pull it up now, I don't think. I don't want to mess up my quiz.
No, you're fine. So yeah, I say anything over 30, we're gonna say normal. All right. Okay, number 5, when using the sample distribution applet when N5 n equals 5, what was the shape of the distribution of mean histogram when the parent population is normally distributed? And
That would also be normal.
And number
6 is when taking samples of n equals 100, what was the shape of the distribution of means histogram when the parent population is normally distributed? So once again, normal. It's scary. It's scary when it's too obvious.
Yeah, I agree. Okay. Kristen, do you want to read the next one?
Sure, we're on 7, right?
Yes.
Yep.
Okay. So when would the distribution of means be normally distributed? The data are drawn from a population that is normally distributed and the sample size is small. So that would be 1. Data are drawn from a population that is normally distributed and the sample size is large. That would also be 1. Data are drawn from a population that is right skewed and the sample size is small. That would not be 1. Data are drawn from a population that is right skewed and the sample size is large. That would be 1.
Okay.
Okay, so the only one is not the third one, right?
Yeah.
Okay, so number 8, which of the following gives the best explanation of the central limit theorem? I wrote this down about 5 times. I was trying to understand it. Okay, I'm going to read them all and then we'll try and pick the... If the parent population from which the data are drawn is normally distributed, the sample x, the sample mean, which is x, will follow a normal distribution. For bell-shaped data, approximately 65% of the data will be within 1 standard deviation of the mean. About 95% of the data will be within 2 standard deviations. Approximately 99% of the data will be 3 standard deviations of the mean. That was that other rule from last week. Okay, so the third one, if the sample size is large, the sample mean will be close to the population mean. Now, the last one, if the sample size is large, the shape of the sampling distribution of the sample mean will be approximately normal.
Well, the third one is for the large law of large numbers.
Okay.
So that one's not it, right?
Yeah.
And the second one's not it. So.
So you're saying it's either the first or the last?
Yeah.
Okay, so this is what I wrote down. The central limit theorem describes what happens to the shape of the distribution of sample means when the sample size is large. That's one of the descriptions I took right from the answers.
Okay.
So the last one talks about the shape.
Yeah.
Large sample size, shape of the sampling distribution will be approximately normal. They both... Sorry.
I was going to say, I think because it mentions shape and that specifically is tied into that definition.
Mm-hmm.
But I don't know.
I think it would be the fourth one, because I couldn't find a satisfying enough definition for the central limit theorem in the textbook, so I checked the answer key, and the definition that it had is the central limit theorem states that if the sample size is large, the sample mean will be approximately normally distributed.
Yeah, that I think so too. I think it's the last one.
Great. Okay, so now we have to find the mean. So let's say a random variable with a population mean of 10 and a population standard deviation of 6. Suppose a sample of size n equals 36 is drawn from the population. What does it mean? Six divided by, right? The square root of 36.
That would be
So
the
we're doing-
standard deviation.
Oh.
Yeah, I think it's the same, right?
Oh yeah. Yeah, it'd be 10, right?
Distribution of sample means.
Yeah, I'm doing it wrong.
Yeah, the mean of the means. The mean of the mean is the same.
Yes. Thank you.
Gosh.
Sorry to confuse you. Okay, now we do the standard deviation.
This is like, everything in this lesson is like it's a little bit the same as something else, but
Yeah.
yeah. Okay, yeah, to then define the standard deviation, that's when we use the
I got 1.
That's what I got.
just straight up 1, huh?
Yeah. Do you 1?
Yeah, sorry, I had to pull up my calculator. Yes, I just got straight 1.
Okay. Now number 11, normal, right?
Yeah.
Population and sample size is large. Sample mean is more. Yeah, I think so. This is like some self-help group. Everybody's normal. You're normal. I'm normal. Nobody needs to feel bad, right?
Right. And then what thing justify your response to question 11?
Oh, now they're really... Okay.
Talking about
Okay, the main distinction I could see between these two theories, the central limit theorem has to do with the shape of the distribution, and the law of large numbers has more to do with the spread of the distribution.
Yeah, the accuracy.
So number 11 is asking about the shape.
Yeah.
So I think it would be the central limit theorem.
I think so too. Kirsten?
Yeah, I agree with that.
Okay. Who wants this in the
I'm gonna look at my answers again, but I think we're okay. Well, I missed that one last time because I just put in the wrong number. I had the right answer, but I just put in the wrong number.
I'll submit mine.
Okay.
Oh, thanks. All right, they're all correct.
Awesome.
Yay. Okay, you guys want to do the homework?
Sure.
Sure.
It didn't seem very difficult, so hopefully it'll go by fast. Hopefully there's no trickery involved.
Oh, they're saving that for the exam. I'm not looking forward to that because, you know, the quizzes as you go along, while it's still fresh in your mind, that's one thing, but
Yeah.
to recall everything on an exam is a lot tougher.
Is it an open book exam? Does anybody know?
I think you can use your notes or a page of notes.
Yeah.
Okay. All right. Are we all on the homework?
Yep.
Let's see. All right. Which of the following is the best statement of the law of large numbers? If the parent population from which the data are drawn is normally distributed, then the sample mean will follow the normal distribution. It's not the second one. If the sample size is large, the sample mean will be close to the population mean. That's the correct answer, right?
Did you say number 3?
Yeah.
Yeah, that's what I put.
But the last one talks about the distribution.
And this, yeah.
So why are you ruling out the last one? What's wrong with the last one?
For the law of large numbers?
Yeah.
Because the last one talks about the shape of it, and the shape is the central limit theorem. We're talking about the spread for number 3.
So the sample mean is close to the population mean. Okay, yeah. I can go along with that.
Yeah, that's really confusing, but I think it is.
Well, they kind of make it seem like they're against each other.
Yeah.
But it's not, it's just one thing. Here's some information and here's some more information. I don't know. I guess a lot of people have confused them or something, so it's kind of weird.
Yeah.
Okay, so number 2, what is the name of the important statistical result that guarantees that if a sample size is large, the sample means will follow a normal distribution? It's not the first and it's not the last, so.
And this one is talking about the shape of it, so I think it would be the central limit theorem.
Okay. I don't. I agree with that, but I don't remember it ever saying that it guarantees that if the sample size is large.
Yeah.
It's kind of,
I just kept, like, I saw the videos and the guy in the video kept saying the law of large numbers is all about accuracy.
oh, huh.
So that's kind of how I was remembering it.
Okay, that's good to know. You know, I did see that somewhere too. Excuse me. It's something about accuracy to do with that. I didn't really know what it meant, but now that you say that, I remember seeing that before.
Yeah. So that's what I just kept. So what I put is the law of large number. As the sample size increases, the sample mean draws closer to the population mean. Because you get more of a sample, a larger sample, so it's going to be more accurate.
Yeah.
So it doesn't really have to do with the shape.
Well, that's kind of what was happening on those graphs that we were generating, right?
Yeah.
The bigger the thing. Yeah.
Yeah. So,
okay.
Okay. You want to read the next one, Kirsten?
Is this number 3 or?
Yeah, number 3.
We're on number 3.
Okay, sorry. My brain keeps flipping out. Okay, a bottling plant fills 1 gallon jugs with milk. The labels on the jugs state that the volume of milk they contain is 128 fluid ounces. Federal law mandates that the jugs must contain no less than the stated volume. The actual volume of milk in the jugs is normally distributed with a mean of 129 fluid ounces and a standard deviation of 0.8 fluid ounces. Plant workers take the simple random sample of 8 jugs, measure the volume of milk in each jug, and calculate the sample mean. Use this information to answer questions 3 through 6. What is the shape of the distribution of the sample means? I think it would be normal because it says that it's normally distributed. The parent population is normally distributed.
Agreed.
Yeah, I think so too.
Okay. Why be normal?
Maybe. Maybe it's a normal distribution.
Okay. So the mean is 129, right?
Yeah.
Yep.
Now we do standard deviation. Oh. Okay. Here where we get.
Sorry, I had to start over.
I did too. I got 0.2828, so 283.
That's what I got.
Yeah, I got 0.8. I'm sorry, I got 0.282. So what are we rounding to?
283.
Three
Right?
decimal places. So 0.283. Okay.
Hey.
Okay, so number 6, if the plant workers sampled 100 jugs instead of 8, which one of the following changes would they see? The mean would the mean would decrease, standard deviation would increase, standard deviation would decrease, sample means would be uniformly distributed. Would the standard deviation increase?
I don't think it would increase. I think it would decrease.
Okay.
Because the more you have, the...
That's true. Yeah. I was thinking there'd be more deviations with a bigger thing, but you're right. It would be less because there would be more that would be the same.
Sorry, I'm just reading my notes for a minute.
It wouldn't be anything to do with the mean wouldn't change, right?
No.
And the sample means would be the same anyway. So it'd be between either standard deviation increasing or decreasing. So we're saying that the standard deviation is going to decrease because there's going to be a lot more samples that are just the same. I mean, this is machines doing this, right?
Yeah.
Machines run by computers. It's probably not going to be too much deviation.
Yeah, I agree. So standard deviation decrease, right?
Yep.
I think I read that somewhere too. I don't know where. That's the problem. Okay. Okay, a team of dermatological researchers were studying skin cancer among 60 to 70-year-old American men. You're part of the research team and take a sample of 70 men from this group and calculate the mean number of skin cancer spots in the sample. Also suppose that it is known that the distribution of the number of cancer spots is right skewed. Use this information to answer questions 7 through 10. How is the standard deviation of the distribution of sample means related to the population standard deviation of the number of cancer spots?
Wouldn't it be less because you have the squared thing on the bottom?
No. I would think so.
So we don't have all the numbers to figure this out, right? We're just going on the information like what the rule would generally be. So you're saying the first one?
Yeah, I would say the first one because there's that square root thing on the bottom.
Less than the population. So it reduces the sample size of 70. I don't remember learning too much about what the... I think you're right, Kirsten, but I don't remember really learning what the standard deviation does.
The standard deviation of the distribution of sampling means would be smaller than the standard deviation of the population by a factor of, and then I have 1 divided by the square root of 10.
Yeah, that makes sense.
So, are you doing less than?
Yeah, that makes sense.
So the standard deviation is for the first one.
It will be less than the population standard deviation.
Right?
Yeah, that's what I'm putting.
If you get it wrong, we have a second chance.
True. If we can figure it out the second time.
Yeah. Maybe I should be writing these answers.
So, yes, for sure. How is the mean of the distribution sample means related to the population mean of the number of cancer spots? So is it the mean of the means is equal to the mean? Would that be the rule that applies?
Yeah.
So the mean of the distribution sample means is less than, equal to, greater than, cannot be sure. So would it be the mean of the distribution of sample means is equal to the mean of the number of cancer spots?
Yeah, that's what I'm putting.
Okay. There was only one study, though. But then, okay. So they only did one study, but assuming you could take it and just duplicate it,
Yeah.
like those charts, then it would be, then you would have more than one mean, right? The sample means. You'd have several sample means. I guess that's what they're talking about.
Okay. Kristen, you want to do the next one?
Yeah. The numbers of skin cancer spots of 60 to 70-year-old men are right skewed. Assuming the sample size is large, which of the following best describes the shape of the distribution of sample means? Well, since it's large, it would be approximately normal.
Okay, that's what I would say.
Yep. Okay, number 10. Suppose the sample size for this study was n equals 2 instead of n equals 70. What would be the shape of the distribution of the sample? Right, skewed?
Yes.
That's kind of silly with two. How can two samples be skewed anywhere? They're just there. That's weird. But since the population was right skewed, right?
Yeah.
So if we have a sample size small, then it would be right skewed.
Yeah. Okay, I'll submit mine.
Okay.
Okay. Oh, it's all correct.
Yay. Sweet.
Yay.
Well, that was not as horrible as I was anticipating.
Yeah, me either. I still think it gets confusing though. So
It is very confusing because there's just so many things that are similar.
yeah. Okay, we did it. We're awesome.
Well, I will send an email to either our instructor or the teacher's aide. See if she wants to contact Eloisa for us.
Okay.
See if she wants to go to a different group or what.
Yeah, there's other groups that seem like they would work better with her schedule, so I think.
Yeah, I think she's just so super busy. I'm not sure any time would be good for her because we did try evening, and she was
Yeah.
like, "Well, I can only meet for 45 minutes or whatever." So I think
Yeah.
she's just super, super, super busy.
Yeah.
But we could take somebody else into our group that
Yeah.
could meet during the day. If I thought there was somebody that was saying, "I don't have a group. Everybody, quit my group or something." But I never heard back from her, so.
I saw that too. Maybe she joined a different group.
Yeah, maybe. Okay, so we're still set for Thursday.
Yep.
Yep.
You guys are still fine with that time?
Yep.
Yep.
Okay, great. Have a great week. We'll see you in a couple of days. All
Bye.
right, see ya.